Hello everyone, my name is Divyan Shukla, a student of BSc Honors in Data Science and AI at IIT Guwahati. And today I am very excited to present you my trimester 7 internship project, Automated SAP System Monitoring using SAP Solution Manager, which I have completed during my tenure at HCL Technologies. The project focused on transforming the traditional IT operations into a streamlined engineering pipeline. Here we have the content of all the future slides that we will be covering in this video. So let's move on to the introduction part. Let's see what SAP is. SAP is a leading global provider of enterprise resource planning ERP software. Okay, and in large enterprise environment, SAP system act as nervous system, managing everything from their finance to supply chain. However, many organizations still rely on manual monitoring. And why this monitoring matters? Monitoring matters because the SAP system requires an 24/7 uptime. Second thing, the revenue is always at risk, and the large enterprises have complex landscape, so we need to have the monitoring setup done. Let's quickly move on to the problems. So let's see what is the problem in manual monitoring. Administrators have to spend 5 to 6 hours daily logging into the multiple different servers just to check the CPU, memory, database growth, background job status, and many more things. And this approach is highly inefficient and error prone. More importantly, it is entirely reactive. Issues are often discovered only after system goes down, leading to a detection latency of up to 2 to 12 hours. And from a data perspective view, if you see, the manual check discard valuable historical data, making it impossible to apply the predictive analytics or a machine learning model we study in our degree. So let's see what we should do. To overcome the manual monitoring crisis, I came up with the six strategic goal. The first will be the automatic system monitoring. We will set up automatic system monitoring, so there will be zero effort in manual monitoring. Second will be the implementation of diagnostic agent, DA agent on host. Third is enabling data pipeline via SLD. Fourth will be the centralized monitoring in LMDB. Fifth will be generating the real-time alerts. And the last but not the least, it will be the setup of EWA and job monitoring. Let's see how each of them will function. What is the architecture in our next slide? Let's walk through the architecture of data pipeline I built. I've deployed the DA agent on satellite host. These agents scrap hardware and application log every few minutes, and this is called our data collection layer. Then we have our data pipeline layer. Here, the data is sent via secure hybrid of RFC and HTTPS protocol to the SLD. The metrics are then stored and synchronized into the LMDB, where the raw telemetry is structured into an actionable metadata. And then we have our analytics layer. Here, finally, the SAP Solution Manager is applied our threshold based logic. In terms of logic, we have implemented a traffic light system. For an instance, an alert is triggered if CPU utilization exceeds a critical threshold. Now move to our next slide. In our system architecture, we have seen multiple components there. Few of them are listed here. Let's see one by one what each one of them do. The first one is diagnostic agent or the DA agent. These are installed on all our satellite system and continuously collects data like CPU, memory, database growth and job runtime metrics and many more. So the data collection job is done by DA agent. Then we have SLD, which using the RFC plus HTTPS protocol to route the data. The data is being routed to LMDB. What is LMDB? It's a single source of truth or the data warehouse. These centralized data warehouse store all the system metrics, which is being then used by SAP Solution Manager. SAP Solution Manager is central command hub. These are used for monitoring, alert generation, configuration of threshold, report generation, and notification dispatch. So all the adjustments are done in SAP Solution Manager. We have system monitoring templates there. So these are pre-configured monitoring profiles, but as we know, different production have different workloads. So we have a customization option here available. So we can just customize it as per our need. Then we have real-time alerts. Once the metrics exceed the threshold, an instant email is dispatched. The email can be dispatched to any team, whichever is being provided in our SAP Solution Manager or in the template. Then we have also set up EWA. These are early watch reports. It is used to identify the long-term trends such as gradual database growth, and many more things. So these data are can be set up by weekly or monthly basis, anything. Then we have job monitoring. These are job monitoring. So we have various job there in our SAP system. So system monitoring is one thing and job monitoring is one thing. So we have job monitoring as well. The same way as system monitoring works, the job monitoring also works. Once we have a failure, we get an alert. Let's move to the next slide. After setting up the automated monitoring, the results were transformative across all the key performance indicators. The manpower reduction, the work that was done by 5 people are now can be done by only 2 people. The error rate reduction, the 20% error rate is now reduced into 5% error rate. So 75% fewer errors. Time saving, the key component. Before that, the administrator used to spend 5 to 6 hours daily. Now, only 2 hours is required, and then it is also when we have alerts. If we don't have alerts, there is no need to spend our time there. So, 67% faster work than before. We have also seen from our past 1 months of test that we have 100% success rate in triggering alerts for critical job failure and CPU bottlenecks. Furthermore, the synchronization layer maintained a high fidelity. We observed 0% data loss for our production S4 HANA systems and other systems as well. During the centralization process into the LMDB, this ensures that the data we are collecting is reliable for further analysis. So the measurable outcomes are really very good. So I think the manual monitoring uh, can be moved to automated monitoring, as we have already checked this in our quality and production systems. So let's move to our further slides and see more. From IT ops to data engineering, the data science connection. Now you might be wondering, how does the SAP infrastructure related to data science and AI? The answer lies in data engineering and predictive maintenance. As we all know, the AI model requires massive amount of high quality data. By installing the DA and setting up automated monitoring, I efficiently build a data ingestion pipeline. We are now continuously collecting structured time series data on system behavior. Currently, the alert system is rule based. For example, uh, the SAP sends an alert if the memory exceeds 90%. However, the historical pipeline I built is the same exact foundation needed for AI. In the future, the data can be fed to machine learning algorithm to stabilize the baseline system behavior and predict anomalous or system crash before they happen. Now we are getting the alerts after the system crash or after the threshold cross. But in future we can use the data to just detect it. In future, if there is going to be any server crash, we can detect it before. So the conclusion here is the project is successfully reducing the manual monitoring hours to nearby zero and drastically improved incident response time. Most importantly, it laid the data groundwork necessary to eventually transitioning IT operations from simple automated alerting to AI-driven predictive maintenance. Let's see what's there in our next slide. Let's see the success and future vision of our monitoring setup. In conclusion, the project successfully bridged the gap between IT operation and data engineering. We just didn't automated a task. We built a robust telemetry pipeline. The future scope is most exciting part for a data science student. With the LMDB now acting as a historical repository, the next step is predictive maintenance. We aim to replace static threshold with LSTM model for time series forecasting and isolation forest for outliner detection. This will allow us to predict system failures hours before they occur, moving from our reactive AI to true AI ops. So thank you for your time. Thank you for listening to me all about my project. And more details are given in the articles, how the setup is done, the detailed information for the monitoring setup and EWS setup. So thank you for giving me your time. Thank you for listening to me.